So I want to talk about a pattern that no one pays attention to, or at least very few do. But before we get started here, let's start with a game. Hopefully your UML skills are up to date. So you were like, what? What's up with the UML here? What do you think, just by looking at this one, I scrubbed everything so you wouldn't be able to tell right away what it is. But given this UML here, what do you think this one is? Anybody have an inkling on this one? Which one? Adapter, huh? Wow, very good on that one. Yeah, good job. So yeah, that one would be the adapter on that, where you have a particular operation on that with a particular interface, and we are extending from that particular interface, and this in turn would extend from that one, and that way it's kind of like a electric adapter, or some kind of cord or things like that. What do you think this one is? Factory? No. Yeah, good job on that one. Man, everyone's on sharp on this one. That's pretty good. What about this one here? This is my favorite one. What do you think this one is? What was that one? No, not composite pattern. I would have, the word is there, so I was like, oh, that must be the composite. No, it's not the composite pattern. Which one? I heard regular. Say it louder. Oh, decorator. Yeah, great job on that one. Good, 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 good. And then finally, what's up with this one? What do you think this one is? It's the one we're going to be talking about today, and that one's called the interpreter pattern, which nobody ever uses, but I think it's going to become more and more important now. So I'm going to talk about the past, I'm going to talk about the present, and I'm going to be talking about the future about this particular pattern. And one of the reasons for this is the following. A couple of resources that I just want to mention here. If you want to know the future of Java, take a look at this particular website, which is openjdk.org, JEPS/0. And this would show everything that is coming up within Java, and it will usually, they kind of change this up a little bit, where they're going to show, some of the new things that are going to be coming up with the Java programming language. If you're out of the loop or haven't taken a look at Java in a while, the latest releases are always coming out, usually like in March and October every year. That's why for some of you are Java 8, you're like, what? We're already at Java 22. Keep track of all of the advancements here. How many of you have heard of Java Almanac? Anyone use Java Almanac? It's a really wonderful resource that you should be able to take a look at. Kind of a side note thing here. But the Java Almanac, I think, is a wonderful, wonderful resource, so that way you could always know like what's new and what's not. And this one again is javaalmanac.io. Here's one of my favorite features for this. Let's say you're interested in JDK 21 and you want to know the differences between 21 and 16. If you click on this, you get to see through the API what's been added, what's been removed, and things have been removed. Kind of interesting. So all this is in here. So great way to check everything that is going on. Now, one of the items that I looked at here was the following. And they just said on this particular JEP, which is 433, they have an evaluate here. And that really just like excited me. And in particular, this one talks about a particular expression, where we are bringing in a particular expression and we're using a switch expression, which is brand new in Java. Have any of you started using switch expressions? Not switch statements, switch expressions. Switch expressions are the switch But what's different about this one is that it returns. That's what makes it an expression, right? Evaluate and then return something from it. That's new. And I was looking at this and it reminded me of Haskell and it reminded me of Scala in the way that we do this. And that's what I'm going to talk about today within this particular presentation. So I'm going to start off with the old, and in the Gang of Four book, which is Design Patterns, Element of Reusable Object-Oriented Software from Eric Gamma, etc. This is the book that started with the design patterns. People often now will berate the design patterns in the design patterns book. Oh, I just want to simplify my code. Why do we need design patterns? I'm of the opposite opinion. I think the design patterns are essential. I think that if you are a programmer worth your salt, and again, great job everyone here with the UML diagrams to recognize the patterns that we are needing. So what I want to do is I want to take a look at the classic pattern within Java. And here is the classic pattern. Let's see, should I do, can you see that okay, or is that better right there? Is that better? Can you see that back there? Okay. So here's the particular expression. I'm going to start off here with a particular interface and a interpret. Now, if you remember that UML diagram, there's this context. A lot of these patterns, the old patterns, will have a particular context, which is, I'm going to hand this to you, do whatever you need, and then pass it over to the next person, next person, next person, and you all, chip into that bucket, which is called the context. And this was a, very big thing that, was used in 1994. So yeah, passing that context around was the thing to do. Now, what was the idea? Well, let me go over here to the runner and view what this one looks like. The idea for a expression was this, right? Or the interpreter pattern. I can create, and the goal was to kind of give some semblance of a programming language within another programming language, and that was the idea for the interpreter pattern. And here it is. This one is new sum with two constants and get the expression. And then what I could do is I can then send in the context, and that would interpret whatever it is that you need. Well, in this particular context, let me come in over here and let's take a look at what this context is going to look like. And again, remember, this is the older style pattern. I'm passing around this particular context. I decided to create a stack for this, and that's what you see here under line 7. And I'm going to have pushes and pops. And what I'm trying to do is I'm trying to emulate those old style reverse Polish notation calculators. Have any of you used those calculators where you do 1, 2, put that on a stack, and then you do a plus, and then it would just turn into 3, and then you could add more to the stack. And so you kind of started doing like this stack-based sort of thing. I decided in this case that's the way I'm going to do it. This is how the evaluation happens. Okay, so in this runner here, what I would do is I would interpret with that particular context. And again, just pass that along. So I would have a sum, and here's the sum right over here as an example. And this is what it represents. The expression on the left and the expression on the right. And I'm going to set those up. And then finally over here is how I'm going to interpret this. And to me, this is the problem, or one of the problems here. The classic interpreter pattern had what it is that you want to do inside of the interpret. The thing is, what if I wanted to do something else? What if I wanted to print out the formulas as a string and not necessarily add them up? I'm stuck, right? That's the issue here. We kind of see this in other places as well. What happens if you don't like the toString of your object? Just out of curiosity, what is it that you do now? Do you edit it and change it? Well, that may break a few tests along the way, right? So what is it that you do? You may create an interface, maybe something called, a two-string object, or use a decorator like we just saw over there. So lots of different ways that you could go about that. So that's going to be one of the problems here when it comes to this particular design pattern. So I have subtract, and of course, what is it that come on, let's go. What is it that I want to do with this? Well, I'm going to do a subtraction here. Here's the sum, here's the multiply, etc., etc. Okay? But it works out pretty well in that if I set up the expression here, and here's the expression again, I have the sum and the constant, and what I'll do is I will interpret given that particular context. And once I have this interpret, since this is a sum, I'll bring this one in, and what I'll do is I'll take the left expression, the right expression, and interpret that and get the context there, and then what I'll do is I'll push back on the stack, and what I'll do is I'll do a pop, and then I'm able to get that particular calculation. And that one worked pretty well. That's a pretty nice way to go about it. And if you got into a time machine back in 1994, you could impress all your friends, right? And that's the idea behind it. I have a few of them here. I have a multiply on this one just to show how that works. And I am going to go ahead and run this. And I see over here the first one. What am I doing? Adding 1 and 3 together. This one evaluated to 4. What was the second one? Here's the second one over here where I'm subtracting 2 constants and adding them up with 6. So here's this one. So 6 plus 1 is 7. And then finally this one over here, okay, which ended up as 6. So pretty cool pattern, right, for 1994. But why would you use this, right? How often do you need to create a programming language inside of a programming language in order to do things? So this pattern was deemed useless. All right, there it goes. Okay. So many years have passed since then, and some new things started coming out, and particularly this JEP over here. And what is that going to do for us? So let's talk about the modern, and when I say modern, I'm going to go to maybe JDK 21, I think, and all the amenities that we have now with JDK 21. Now, that classic pattern has this issue here. Domain model, rich methods, which are rich business methods inside of the class, and then the interpretations, right? How do I interpret things, right? Like I had multiply, I had constant, I had, subtract, those were the interpretations, and they were locked into that particular object. And again, the problem here is, what is that doing here, right? And so what's up with that interpretation? And where's the interpret in the interpretation? Bad things from the 1994 one, and again, everyone's just trying to do their a good job. But the 1994 version of this had mutability, and number 2, the mixing of concerns. The interpretation should not be a part of that class, and I don't know if you agree or disagree, but that just seems like something that should be outside of it. For your domain, that should particularly just be the like if you're doing some of the models, that should just be, hey, I got an account with the first name, last name, and account ID. The interpretation should not be in there. They should be external, because what happens if I want to create a different kind of interpretation, right? And that's the idea for that. Lack of lambdas, lack of composability, no pattern matching, no seal types, right? And again, you could go into a time machine, go back to 1994, and you're not going to have those things. So the interpretation in the old style is that the interpretation is baked in, and that's not good. And so, I don't have to look at the classic pattern again. You saw what that is. But again, it was 1994. So one of the other things that I learned is this right over here. I'm a really big fan of Haskell, Elm, and PureScript. Elm and PureScript are web-based. So if you want to take, if you're bored with your TypeScript on JavaScript and you want something with a little bit more of an adventure, check out Elm and check out PureScript. These are Haskell-like languages that are on your browser that you can use, and they get transpiled into JavaScript on the back end. But the way that language works, Haskell, Elm, and PureScript, is that you have what's called an anemic model, okay? Which is, I'm just going to describe an object with its properties. That's it. No rich methods at all. So the Java, C#, DDD style, the domain-driven designers, they really like the methods. They love rich methods, and that should be, a part of that particular domain. Well, let me come in over here, and let's take I thought I linked that one. Sorry about that. Let me just add a link to a web page. There we go. And then we can take a look at that one. All right, here we go. So here's what a Haskell looks like. Anybody do Haskell or tried out some Haskell? Okay, 1, 2, okay. Give it a try. I think, understanding this language, you know what? I just thought about it right now. I know that Brian Getz or someone told me, he didn't tell me directly, but he's really into Haskell. So if you kind of want to see into the future, and that's the thing here, if you kind of want to see into the future as to what Java may or may not be like, take a look at Haskell. There's a lot to take in here, but let me go down. I'll come back to that first one, but let's take a look at a calendar. These data things that you see right up over here, those are essentially kind of like what classes are in Java, right? I have day of week, I have month, and those are the objects that I wish to use. And this one right over here, this month, it looks kind of freaky, but what this one means is this is a method that is called month, and you give it a month, and you give it a day of the week, and you give it an integer, and that returns a string. So this is always the return type, and these are going to be its parameters. But what you see over here is that these are anemic. They're called anemic objects because that's all it does. It's a holder of information. If you want to act upon it, then you do that from the outside, right? Let's come in over here. This one's really interesting on here. Take a look at this one. I don't think this one has any kind of particular objects, but lo and behold, take a look at that one. Interpreter pattern. So when you do more and more really hardcore functional style programming, interpreter pattern, interpreter pattern, interpreter pattern, and that's the point of this presentation. Get used to it, and this is going to be a very common thing on how you interpret things. Okay? And we're going to be in a very odd place with this, and that is, here's a Martin Fowler article. He calls it the anti-pattern for this. It's been around a long time, yet it seems to be having a particular spurt at the moment. I was chatting with Eric Evans, DDD, on this, and we both noticed they seem to be getting more popular as the boosters of a proper domain model. This is not a good thing. So, kind of odd, right? Martin Fowler does not agree with that anemic domain model. Again, just holding the properties. That's what an anemic domain model is. But when you use your Haskell, when you use your Helm, that's the way things operate. So what do we do in Java, coming back and circling into Java? The anemic model in Java probably is going to go too far. Again, we are still a object-oriented language. We're not and I got in trouble for saying this. I stated that Java is becoming a functional programming language. And that's not true. And I had to learn my lesson on that. The thing is, though, we don't have to include everything, but everything that has to do with a model should be in that particular model, right? If I have an employee with an employee ID and a first name and last name, the methods on there should have everything to do with those properties, right? Those member variables up top. But if they don't, that method should not be there. And we kind of learned that over time. It's called cohesion, right? With the member variables, if you have methods that don't interact or really do anything with those member variables, they should find another home. They should go somewhere else. Now, in order to achieve a more modern interpreter pattern and what that's going to mean for us, let's talk about sealed classes. How many of you have started using sealed classes already? Okay, let's talk about it. So what I'm going to have here is I'm going to have a sealed class. And let me start up with, I'm going to start with my option here. Right? How many of you love optionals, by the way? All right. absolutely. So great stuff. Well, what I want to do on this one is show, I'm creating my own option here for this one. And I'm doing a little bit of a pattern match with this, where I'm doing a do match with a my sum. I'm also creating something called my none. Now, the optional that we use in Java is empty or present, right? You do an optional of and put something in there, and that means that we have something available. Well, what I'm trying to do is I'm trying to create the Haskell way to go about it. In Haskell, in Scala, we have two objects called or sum and none, right? Yeah, sum and none. And they belong to a family. So if I come in here, here's my sum, and here is option. Now, what is option? If I take a look at this, here it is. What the heck is this thing? Well, this is a sealed class, and the way it's settling in my brain as to how I understand sealed classes is that I have a parent called option, and it has children, and that's it. So it's really, let's close how many children this has. It is the same as final, and it is the same as abstract, but all the extensions are coming in from my option, right? And that's the idea here. It's a closed-knit family. Now, if you're thinking, wait a minute, isn't that what enums do? So here's the thing, and this is the way I'm, just kind of mentally separating. When do I want to use a sealed class, and when do I want to use an enum? I'm going to go with the arguments, right? If you remember let's come in over here. Do you remember the planets? Here, let me go planets, enum, Java. So if I come in over here, I think we've all remembered this one. Let's go down all the way over here, right? We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune as the planets. But what do we know about this? They all have a mass, and they all have a radius, and there it goes. Okay, so the idea for that is same number of arguments, right? Every planet has a mass. Every planet has a radius. And it's a closed set, right? All of these, that we only have these planets other than Pluto. They should include Pluto in here. But that's a closed set. And they have the same attributes. But what if we don't have the same attributes? That's going to be the important thing with this. So, for example, my none, or the thing that's representing none, has no arguments in it, right? You see that. But if we go over to sum, and here's sum right over here, I have one argument. So it's exactly like an enum, but the thing is, the arguments are going to be different. If the arguments are going to be different, then what you want to look for is a sealed class. The other benefit that you get from this is that these are pattern matchable. Right? So if I have a type that is called option, and I think here on the test we could have an object, pretend there's an object there. Here's the object over here, and this is the pattern match. Oh, instance of my sum, if this is going to be a my sum, then I'm going to go ahead and grab that argument. This is new as part of the pattern match here with this MS here, right? If it is equal to that, I don't have to do the casting anymore. MS here is just going to be representing a my sum. And I'm able to do a toString on that. Otherwise, if it's a none, then I will just say that that is a toString. And if I go ahead and run this, we will see over here that I'm able to get the item out of it, right? And that's what a sealed is. Here's another example for sealed. And here's this one here. This one is shapes. And if I take a look at the shape permits circle, triangle, and rectangle, right? Closed set. The parent defines who the children are. You typically can't, extend from what the parent has with a little bit of a particular twist. So let me come in over here, and here's circle, right? So if I determine the radius, and a circle has a radius, right? That's the way that shape looks. And this is a perfect scenario for using a sealed class. Triangle, how do you define a triangle? Base and height, right? That's different properties for it. But they should be all a part of the same family, so that way we could do a pattern match on it. Here's rectangle over here, and rectangle has length and height. Again, different qualities for that. But if I take a look at rectangle, I think one of the other items here is that I have a square. So I could extend from one of the children and create a square, or I can go to a parallelogram, wherever that one is. There it is. Parallelogram is extending from rectangle. And the reason why I'm able to extend from rectangle is this. So any one of the children you could highlight as non-sealed, and that means that that itself can be extended from there. But the inner circle, that is sealed, right? And that way we could do a pattern match against it. Cool? Gets crazier. So pattern matching. Let's talk about all the different pattern matching that we have now, and then let's revisit the interpreter pattern, and I think you're going to like this. So let's do some pattern matching right over here. And inside of my test right over here, I'm going to take a look at some of these here. And this is getting more and more advanced. If you go to the JEPs on the website, one of the things that you're going to see is pattern matching has really, I think, been active since, I don't know, 2018 or something like that. It's been ongoing, and they're adding more and more to it. And the fact, the pattern matching, one of the latest ones is how do we pattern match against a primitive. So this is getting more and more advanced over time. But here's what a pattern matching is. If I come in over here and do a match, here's what that looks like, right? Oh, instance of string, right? We're looking for a string, and this is automatically going to assign a S to it, right? And if that's the case, then I could say hello to you. Otherwise, if it's an integer, I'm going to assign that to an I and then just go about my business. Great. We could do string matches. We can match nulls as well. Let's take a look at this interesting one. Case null, case foo, case bar. In case it's foo or bar, we're going to say great. In case it's a string, part of the pattern match here, I'm going to take that string. It's going to have a variable x, and I could take that variable and do something with it. Okay? So, pretty cool in the way that works. Yes. Beautiful question. No more breaks, and we use this arrow system as well. Yeah, the switch statements I abandoned, right? Long time ago. I didn't want to use them. They were useless to me, and they were ugly. But this is great. I absolutely love this. So this one will do a system out print line. We can have multiple what? Yeah. Mm-hmm. Yeah, and then the thing is, when it comes to the pattern matching, and how is that related to the sealed classes, remember, like as far as the shape goes, I had triangle, I had rectangle, I had the other one, circle, right? And so if I try to do this with a pattern match, then it knows who the family is of that shape. So if I'm not covering every possibility, this would let me know, and that's part of that power that we get from it. So we could match on a record. Ooh, this is one of the more advanced ones in this particular case. If this is an instance of team, and this one came out in JDK 21, take a look at this one. O instance of team, match city, state, or I'm sorry, city name, wins and losses in this particular case. What this one is called destructuring, meaning that if I have a record, this is called record pattern matching, I'm able to extract each of the individual elements. That's crazy, right? Here's this one here. So this one is a switch on a particular object. I don't know what it is, and so therefore I'm going to have a case here. So this one is team, break things up, but if it's an integer, if it's a long, if it's a double, if it's a string, or if it's a default, go ahead and get what you need. Again, this is, I have this return statement here. This is an expression, not a switch statement. So it does return something from it. So these are the tools that we can use to modernize the interpreter pattern. This is brand spanking new in JDK 21. Unnamed variables. Let's see what we're dealing with here. So what I have here is I have a switch of an object, and what I want to do is I want to match on that particular team, city, name, but take a look at this int. This one is just stating I want this to be an int, but I don't care what the name is because I don't really need to use it. Is this Java? And what's this one over here? I don't care what it is because I don't really need to match against it. This is crazy, right? This is Java. And again, JDK 21. If it's an integer, I'll grab it. If it's a long value, I'll go ahead and grab it. Okay. Here's another advanced one. Take a look at this one. Team, city, name, and I don't care, and I don't care. Those are the wins and losses, so I'm not using it for whatever it is that I need. But in this case, this is a team from here. So this is team name from this city, and it's a city that starts with M because I have a when clause as part of it. This is called a guard. Okay, so I am qualifying it with some extra items. Here's team once again, where I'm just formatting any other team, but this time it's not with an M, and then here's the rest of that pattern match. Wow, right? Pretty cool with all that. Questions or statements? Okay. So what's our point here? What is it that we're doing here? Well, we're talking about the interpreter pattern. Can we use sealed classes? Can we use pattern matching to work on the interpretation? And there's a Haskell inspiration that's happening. And this is why I always advocate that you take on some Haskell. It is hard, I'm not going to lie to you, but it's very enlightening. So you notice that with the new JEPs that there is a movement towards interpretation outside of the model. And therefore you can have rich models object-oriented style, but not everything has to be there. And that includes the interpretation. How is it that you're going to interpret all this information? So as a proposal for modern Java, this is what we are looking at. The interpretations are outside, or should be outside now. Your domain model and the rich methods for it, keep that as object-oriented. But the interpretations could be externalized. You don't have to keep that in there. And then whatever services that you need, you can use whatever kind of interpretation that you would like, and then you would get the result from it. Okay, let's bring it all together now, and let's take a look at a particular Java version. All right, here we go. We are going to look at a more functional one now. All right, I'm going to start here with the expression. Same one as before, but this time, here's what we have. My expression, sealed class, right? I should only have certain members as part of it. It should be a closed set. Constant, sum, subtract, and multiply as part of that particular expression. That's the idea here. Now, if I take a look at multiply, here it is, and that is a record. Yeah, it looks kind of anemic, but if I wanted to add any kind of particular methods to this, I could do so. But I'll show you in a little example here in a bit. But that's the idea for it. Again, the thing you'll notice here is that there is no interpretation inside of this record, right? That should never have been there to begin with. Now what I'm going to do is I'm going to bring in this runner here. Everyone okay with this so far? Okay. When you go and take a look at Haskell, when you take a look at languages like Scala, there's going to be a couple of terms. One of them is going to be program, which means these are the objects with the relationship, the programming language within a programming language, and that's what we're looking at here. Okay, so you'll often find that term, and here you're going to see the benefit of externalizing that interpreter pattern, and here it is. I have an expression, I have a program, which is multiply some constant with 40 and 60. How is it that I want to interpret that? Oh yeah, here we go. So I could do a wide range of things. I could evaluate it and take a look at this evaluate. I'm bringing in the expression here, and what I'm doing is I'm doing a switch on it. If there's a constant, I'll go ahead and grab the number for that. If it's a sum, I'll go ahead and get the left and right, and then I'll do a recursion again to evaluate the left and right hand side where I'm doing a plus. Beautiful, right? Because the problem with the original pattern is that you were locked in that it was going to do math. But this time I'm externalizing it. That's fantastic. Here, I don't know what's up with the microphone. Here is the subtract And obviously I am going to subtract that, and here's the multiply, and what is it that I'm going to be doing. In fact, I think I could rewrite this one, and I could just say C in this case, maybe. Here, let me call it number. So this is part of the record pattern matching here. This came in JDK 18, I think, right? So if it's a constant, I want to extract the number from that constant, left and right, and again, I'm just going to do the evaluation here. That's fantastic. But wait, there's more. How about I go to evaluate print? Again, that program can be reused in different ways. What if I want this? And by the way, this is probably JDK 22 with the enable preview turned on. Hold on, I'm going to cry. Oh, man. And it is str. So we have string interpolation now in Java, okay? Which I think is still in preview mode, but you get the idea here. So what if my interpretation is I don't want to actually add things, I just want to print them out and make it look nice. There's my interpretation there, right? Separate interpretations for a particular use case. And there it is. Nice, right? What about this one? I sound like a salesman, right? Oh, what about this one? Did you know you can do things asynchronously? So given that program, given that particular language, how about this? Here's an evaluate async, right? I have a particular language with constant, with sum, with subtract, with multiply. But this time now, take a look at this. If it's a constant, what I'm going to do is I'm going to create a future from that, a completable future. How many of you are using completable futures? Okay, good. All right, excellent. But yeah, here it is. Here's the completable future. Here's the sum where I'm evaluating it async. Here's the subtract here, and here's the multiply. So if you have a program, you can interpret it in multiple ways. The old interpreter pattern, terrible. But doing it this way, you can interpret things however you would like. Cool? All right. So yeah, very awesome. Let's see. I think that one's pretty good. What I want to do, yeah, there's the future here. I got another example here. What happens though, and here's the thing. What happens if I want to do things like flat map and map? Okay, this is where we're reaching the boundary of Java right now, right? How many of you are really good at flat map now, just out of curiosity? Okay, flat map, essential. It's called a monad, right? So if you ever hear that term monad, that's what the term flat map is all about. So I have this expression here, and if I ever need to do a flat map, I don't think there's a lot of choices for me except to put that flat map here in the particular class, right? So we're kind of heading back into like the object is taking on too much here. I think it'd be great at some future moment to be able to extract the flat map and the map into what are called type classes, but it is what it is, and so therefore I have this flat map and map in here. And so what am I able to do with that? Well, let's take a look at the runner over here, and here's an example here, okay? As to, here's the evaluate, here's the print, but what if I have an expression where I want to do a map on it? And here it is, right? For the argument that is internal to this, I want to do a map where I just want to multiply either one of these, okay? Or a flat map. And here's the flat map over here, okay? So that's where things are going to get a little bit weird, at least for now, until, you know, we try to think about what it is that we want to do with the language. So what is the future? I don't know. I don't predict the future. I just, you know, just take a look around and maybe just take a wild guess. How many of you use Scala? Okay. Type level cats, I know if you're not using Scala, you're not probably using type level cats. Well, let me talk about that one. Scala, I think, is an important language, particularly within the JVM. And certainly, I don't think many of you, your production code is ever going to be using Scala, for example. But you learn a lot from it. Maybe it is, and maybe you're going to be in a particular company where they use Scala. Scala is very, very cutting edge. They are not like Java in that, Java takes a long time to bring a feature into the language, right? Because that backwards compatibility is vitally important. Whereas Scala is like, woohoo, let's do it. Let's go ahead and add these cool little features to it. The thing is, though, it is a very functional language. It's a trailblazer of new features in the GAVM, particularly when it was stagnant. Long time ago, was it 2000, around 2004, Java didn't have a steward, right? No one was taking care of Java. Sun Microsystems was either going out of business or they were out of business, right? Who was going to take care of Java? Oracle hadn't purchased it yet. So it was stagnant, bad timing, because multi-core processors started coming out. And so Java was getting close to being irrelevant. Oracle then took over and they started adding some of these features. But before Oracle, Scala said, I'll help, I'm here. And so that's where they've added a lot of these particular features. So Java was very much inspired by Scala and a lot of the work that they did. So much so, there's a language called Kotlin, inspired by Scala as well. There's another language called Swift, also inspired by Scala, okay? So again, Java is slow, and I don't mean that in a hard, terrible way, but again, they take their time, and that's a great thing for all of us to adopt certain features. Seal types came from Scala. So how that happened, we see that there in Scala, and pattern matching as well. And again, Kotlin is another language for that. And there's another one called type level cats. And so what this is going to afford us is the ability to use a flat map outside and define what a flat map is. Define what a map is outside, not inside of the object, but as a behavior that is outside. So this is showing that we are getting better and better at defining models for whatever is absolutely necessary, but get rid of the interpretations, get rid of the flat map, get rid of the map, get rid of the filter, get rid of all that. Those are just behavioral concerns that we have outside. Oh, sorry. All right. So monoids, what are those? Okay. Monoids are, how do you combine things together? That's a type class. It's kind of like an interface. Functors, that's map. Applicatives, it's kind of a funky little map, but you can map a function into a particular value. And then monads, just flat map. And these are just interfaces that define that. So like I said, domain model, rich methods, the interpretations, get that out of there. The functional methods like your flat map and map, get that out of there as well, okay? And so this is becoming a little bit more clear on how you want to program things. So let's take a look at a possible future here, and don't get too scared here. I'm going to head over to Scala land here, and I have this particular project here for Scala. I'm going to open up this particular program here, and you should kind of see nearly the same thing, okay? Sealed, ooh, cool, right? That's where Java got it. Constant, multiply, subtract, and sum, where I have this particular program, which is the expression here. And what I could do here is just do an evaluation for it, very much like the same way that we have with Java. So now we have an equal pairing for all of this, right? Pretty cool. But let's go over to this one right over here. And this one is going to be very interesting. And here it is. Anybody ever hear of an either type? An either type, we have one over there. And an either type is a representation. It's defined in a class, and it is defined with the left-hand side being the error and the right-hand side being the correct value. So in a Scala, we hardly ever use like a try-catch block. We do things like a either or a try in this particular case. Now, either is monadic, and the idea for this is that we can do some pretty fantastic things like this. And what is this? Well, let me come in over here And I'm going to head over here to Scala. Stand by. I'm afraid this may not work. Oh, it does. Yay, thank you. Maybe. But here, let me come in over here. If I have an option, I don't know if you've seen this pattern yet. We have it in Java as well. So let me just describe that here. This one's called an option, and just very much like in Java. And here's what a flat map would do. Flat map, let's say I want to take that value that's inside of it. I'm going to take another option, and here it is. And I'm going to do another flat map on that. And that will be called Y. And what I'll do again is I'll do an option of 30. And what I'll do here is I'll do a map and call that Z. Right? Have any of you seen this? It's also available in Java as well. And here, let me try to do a J shell for that one. I'll do both at the same time. Yeah. Here we go. Let me go ahead and do that one. Here's J shell. Same sort of thing. Optional of, I'll do 30. Flat map. I'll call that one X. Different kind of arrow on this one. Optional of 20. Flat map. And then I'll have Y, and then I'll have another one here, optional of 10. Ooh, yeah, there it is. And then finally I'll do a map over here, and I'll call that Z, and what I'll do with all this is I will do X plus Y plus Z. Have any of you seen this pattern before? That's Java. Flat map, 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 map. Right? Or flat map, map, or flat map, map, right? And it's kind of interwoven, right? You kind of see how that looks, right? It's beautiful, right? I have an optional of 30. I'm going to get that value. That's going to represent X. And then I'm going to interweave the 20. I'm going to interweave the 10. So what? It looks great. But here's the benefit of it. If anything in the chain is an empty, then the whole thing is empty. How many of you used Groovy before? Okay, do you remember the Elvis operator? It was a question mark with a colon, it kind of looked like Elvis. And it was a way that if something was null, then it would break the chain and the whole thing would be null. It's kind of very similar to that. And if you do Kotlin has kind of like a question mark that could represent that this was a null. This is a more mathematical foundation sort of way in order to do it. So if I state here that this is empty for this one, and let's see, what language am I in? I'll do an integer here. Let's see, hopefully I'll do that right. The whole thing is empty, right? Something along the chain, if something on the chain is bad, then the whole thing is going to be bad, right? That's the idea of a particular flat map. You have built-in error handling. So therefore, you don't need try-catch or any one of these, because that's what that does. That's called, monadic programming, that if anything fails, then the whole thing fails. Well, Scala has this one other thing, so let me go ahead and finish this one. Same sort of thing, flat map, map. And then what I'll do is I'll do X, Y, and Z. I think that ought to do it. Yeah, there it is. Okay. And there we go, right? 30 plus 20 plus 10 is going to be 60. If any one of these is going to be empty, right? It's all done, right? It's empty. And that's the way that we can do error handling as part of it. So, everyone okay with that? Weird, awkward, mysterious, fun? It's a lot of fun to think about things that way. Oh, let me add this one thing. So this pattern, let me go to this first one in here. We can write it a different way in Scala. And it looks like this. This is, here, let me do it this way. Here's the before, and here is the after. So I'm going to do for X. There it is. And what I'm going to do is I'm going to write it like this. I am going to take Y, which is the option of 20. And then I'm going to do Z with the option of 30. There it is. And then what I'll do right over here is I will yield back X plus Y plus Z. And there it is. Same sort of thing. okay? X plus Y plus Z and everything is within the option. And again, if anything in this chain is ever broken, then what I could do is I could do an empty of an int. Again, if anything is going to be empty, and I try to run the whole thing, then the whole thing is going to be none, right? And that's beautiful. So, what's the point in all this? Well, the point in all this is, take a look at the following here. For evaluate left and evaluate right. Why does this work? Because I'm using an either type in this particular case. I don't know if Java is going to go in this direction. I hope it will, but again, they have some other things in mind. They don't want to scare the general public on this. And this kind of stuff is scary. I'll just be honest with you. Scary stuff afoot here. But yeah, right over here is the evaluate left, evaluate right. This means I'm extracting it from that box. In this case, this would be the expression, and I'm going to yield that back, okay? Here is the subtraction, here's the multiply, and then here is the divide right over here. Now the divide is, and here's where I have my error, right? If someone's going to try to make this one a 0 in this particular case, then I'll have a message on here where I'm going to return a left, which means this didn't work. I got an error from this. Otherwise, I'll keep a right, or otherwise, I'll just go ahead and compose this using a particular flat map in this case. But wait, there's more. The thing about Scala, and again, I think it's a good thing to study a Haskell and study things like Scala. Take a look at this one, and here, let me go ahead and expand this one here. This is what's called a type class, and you'll notice here, this just got really, really clean. And a type class is going to be the following. I want to bring in an expression, and I have a numeric and I have a fractional as part of it, okay? So this means that if I'm bringing in an expression here, this expression should be a fractional and it should be numeric. In fact, I think they're both kind of the same. Fractional will be like doubles and floats. But, oh no, let's do that, I'm sorry. Let me go and bring this one in. Will that work? Yeah, I think that would work. So as I bring this one in, here it is. Hopefully that should run. And then finally I have the division over here. So there's the evaluator portion, the interpreter of this. And it's a very, very common thing that we have. And if I try to run this, oh, and here's the best part. I'm going to undo this one. And this is going to have an error. Why is this going to have an error? Because this program is using 40 and a constant of 60. Here's the thing about doing these kind of type classes. The best part about that is I only create one method. Wow, what? So this A in here is a part of the expression, but in this case over here, I just want to make sure that it's a fractional type, so that way I could do a division. And so if I try to use this with an integer, and that's what this program is an expression of int, that won't work because that's not a fractional. Right? So I can keep things from being called on this particular method, and the type system is going to help me out. That is fantastic. So, I can't do that, nor can I do this either. Right? I could only use a program, or, the language for a float and double. I'm going to finish up with this last one right over here. And it can get fairly advanced. But here, let me show you the point for this one. Now, there's some setup that you would need to do in order to do this. But if you take a look at this, this is a program within a programming language. I showed you what a for comprehension is, and this one is stating here, put wildcats 2, update wildcats and make that 12, put tame cats in at number 5, and go ahead and get wildcats, get that number, and then delete tame cats as a language within another language. And that's the idea behind this, right? Now, I'm not going to say that part's easy, but for something like this, one of the things that you would do is you would have a setup so that your users can just focus on this, and that will be easy for them, and then they could create a program for it. And then once they have that, somewhere on here, it's just something like run your program using a flat map for that. Where's that last part there? So the only thing that they would need to do, it's somewhere on here, yeah, here it is take the program, do a fold map against it, and interpreter. Those are the only two things that your end users would do. Now, you're going to be doing a lot more work in order to do this, but for anyone who's using your program, think about Hibernate, think about other kinds of languages that you want to create within another language, and that's the kind of thing that you would get from it. Okay? All right, so I have about 4 minutes left on this. Let's come in over here, and I'll have a thank you onto this one. All right, so what do you think? Pretty exciting stuff, perhaps in the near future. I'm not sure that free monad or cats or all that functional stuff is going to be coming in. I would bet something very similar to that is going to happen, and our interpreter pattern is going to change in the near future. Okay? Groovy. Thanks, everyone.